Hello students, today we are going to start with the DevOps, right? So this DevOps syllabus is based on Government College of Technology, Coimbatore, and it consists of 5 units. So in under first unit, we are going to see first chapter in this lecture. So the 5 unit, what the contents of all the 5 units are introduction to DevOps, and the second unit consists of containers, third unit orchestration, and fourth unit CI/CD pipeline, and fifth unit is monitoring. So first, we will start with the introduction of DevOps with the first chapter one. So this chapter one is available in Learning DevOps textbook, which is represented by Michael Kreff, right? So So now we will start with this chapter one. So these are the content of chapter one. So we can here you can see the content. Chapter one consists of getting started with DevOps, implementing CI/CD and continuous deployment. In which we are going to see about the continuous integration separately, continuous delivery separately, and continuous deployment separately. So next we are going to see about understanding IAC practices, right? So infrastructure as a code is represented as IAC, the benefits of IAC, and the languages and tools which are used in IAC, along with its topology and evolution of this DevOps culture, right? So these are the content we are going to cover in this lecture. So first topic is introduction to DevOps culture. So here you can see the definition. DevOps is a culture and professional movement that improves collaboration between development. So let me increase the document size. Right. So DevOps is a culture and professional movement that improves collaboration between the development and operation team. Right. So DevOps is consist of two words, development as well as operation. Right. So it is going DevOps is going to integrate both development part as well as the operation part into a single one, which is represented as DevOps culture. So now we will see the main goals. It is faster software delivery, automation, and improved efficiency. Right. So since we are integrating development and operations into a single phase, it is of faster delivery, and it also provides automation and improved efficiency. So next we will see the challenges in traditional IT. So silent teams lead to slow software releases, manual infrastructure changes cause inconsistency and errors, right? So our main goal in DevOps culture, it should be a faster one, but in traditional IT the software releases are slow, that leads to siloed teams, as well as the infrastructure changes are represented manually, and it is represents the inconsistency and errors. So this is the DevOps culture representation of diagram, right? So if you see here, it consists of three circles: collaboration, process, and tools. So the collaboration consists of, we have already seen it, DevOps is of two phases integrated into a one phase, which is DevOps. So development as well as operation phase is represented as collaboration, right? And then in the process, it consists of cycle of process that will undergo while you are doing this DevOps operation, right? So it consists of, first you have to plan, and then you have to code, then you have to continuously integrate that code and deploy the code, monitor it, right? And after monitoring, if there is any changes, once again it go for planning, coding, continuous integration and deployment, and again you have to start monitoring. So it is a cycle of process that is done in this DevOps culture. Next we will see the tools. which are required for implementing this configuration of the process, right? So the DevOps culture consists of these three concentric circles. One is collaboration, second one is process, and then the third one is tools. So that's all about the introduction about DevOps. Next, we will move on to core DevOps practices. So as we said earlier, it is consist of CI/CD pipeline, right? So that is what we are going to discuss in this core DevOps practices. So what are the things we are going to discuss under this core DevOps practices? First one is continuous integration. Second one is continuous deployment, and third one is continuous delivery is the second one, and then the third one is continuous deployment, right? So this is how we are going to see. Second is continuous delivery and third one is continuous deployment. So first we will see this continuous integration. So here the developers plays a major role who will frequently merge code and that will be shared in the repository instantaneously, right? So they will develop the code frequently and then they will merge the code to the main branch and that will be shared in the repository. And so that is what represented in the first point of this integration, continuous integration. And automated testing helps catch errors earlierly. In the development phase itself, we will have automated testing which will catch the errors at that stage itself. And this diagram represents the continuous integration diagram. So if you see here, what we are going to do here, first we have to push the code. So you may consider this is user 1 and this is user 2, right? So similarly we will have so many number of users who are collaborating in this integration process. So both will push the code into SCM, which is nothing but source control machine. SCM is nothing but source control machine. So the code is pushed into SCM. Once it has been pushed, it will send to this building which is in CI server, continuous integration server. It will start building based on the test, automated testing results, right? So if the test, any one of the test fails, once again it will go for the user end, which is the developer, who will refine the process, and once again he will send it, right? So you can so this is the process cycle already we have seen, right? So if there is any modification, it will follow the cycle. So if you see here, monitor it and then once again it will plan and code, right? So same process is following here in this continuous integration, right? So these are the stages that are available in continuous integration, that is development stage, and then the developed code is pushed into SCM, and then the pushed code is built and then test against the automated test cases. If any test cases fails, it will give the feedback and once again it will be refined here. So next is continuous delivery. This ensures software is always in a deployable state. So here staging is the main concept of this continuous delivery. This ensures that the software is in deployable state always, and automates deployment to staging environment. So that is what I told. So staging is the main process of this delivery pipeline, right? So delivery phase, it has to stage the content. So staging is the main part of it. So it automates deployment to staging environment, and tools that are set up for CI CD is also which is required for this implementation is also available in this delivery stage. So it ensures software is always in a deployable state and automates deployment to staging environment, and tools that are set up for CI/CD is these are the contents that are available in continuous delivery. So now let us see little more bit about this continuous delivery. So first one is package manager. This constitutes the storage space of package generated by CI and recovered by CD. CI is nothing but continuous integration, and this is continuous delivery. right? So the managers which are used for this continuous delivery, the first manager is package manager. So this manager must support feeds, versioning, and different types of packages. So for a particular code, we will have different versions of the code that will be provided by this versioning, as well as for the code, what are the packages that are required, that will be supported by this different types of packages. There are several on market. So for this package manager, example of package manager or Nexus, ProGet, Artifactory, and Azure Artifacts. So next comes configuration manager. This allows you to manage configuration changes during the continuous delivery process. This allows you to manage configuration changes during the continuous delivery process. So the tools include configuration mechanism with the system of variables, right? So the package manager is to manage the packages. Example of Nexus, ProGate, Artifactory, and Azure Artifacts. And this configuration manager is to monitor the code and manage the configuration changes during this continuous delivery. Okay. So next we will represent how this is represented in the staging environment, and the staging environment is triggered as follows, right? So automated code should be represented in the staging environment. We are going to explain the staging environment now. So it can be triggered automatically following a successful execution in a previous environment. For example, we can imagine a case where the deployment in the pre-production environment is automatically triggered when the integration test has been successfully performed in the dedicated environment. Right, so it can be triggered automatically in the staging environment. And then it can be also triggered automatically, as well as it can be also triggered manually. Both cases are possible. So it can be triggered manually for sensitive environments such as production environment, following manual approval by the person responsible for validating the proper functionality of the application in the environment, right? So automatically what it will do, it will do automatically up to the staging, right? So the triggers will be work. So triggers are nothing but if something happens at the particular, for example, if you keep a condition, if it satisfies the condition, the trigger activates, right? So once the trigger activates, it will automatically execute the previous environment. That is what automatic triggering, and then manual triggering. So this is for sensitive environment. Staging environment will go for automatic triggering, and then while you're going for production of the staging environment, it will be triggered manually. The manual triggering will be validated by the corresponding responsible person after the functionalities are approved by him. So now let's see the diagram for continuous delivery. So it is similar to continuous integration, except it includes the staging representation, right? So here if you see in this continuous integration, right? So just we are building it and then we are testing, right? So that is what continuous integration. But in continuous delivery, we will have the same pushing of code, as well as SCM will be available, and then CI server will be available. So this is the part what we are representing as continuous integration. After this, we are representing to the staging environment, which is done by continuous delivery, and for placing in the staging environment, the trigger will be executed automatically. And once the acceptance tests are gone through, it will go for production, and that will be monitored by the validators, which are who are available here, will be validated manually, and that the product will be sent to the production environment. right? So this is what continuous delivery. So it integrates continuous integration along with the delivery process. So integration, it consists of pushing of code to SCM, which is source control machine, and then it is building the code, and then it is testing against the test cases, and then it is going for staging in continuous delivery, which is triggered automatically. So auto is represented here, and up to accept and test, the triggering will be auto, and then for production the validation will be done by the experts, and it will be given to the production environment manually. So next we will see continuous deployment. So there is a slight change in the continuous delivery and deployment. So in this delivery part, we have represented the validators as manual, which is sending the product to the production. But for continuous deployment, this manual will be changed to auto. So that is the only difference. So we will see continuous deployment here. Extend CD by automating deployment directly to production, right? So that is what given here as continuous deployment, right? CD is nothing but continuous delivery. So it is just extension of continuous delivery, which is represented as continuous deployment. So it is rarely implemented in enterprises because it requires variety of tests, right? So some of the tests are given here, unit test. So this will test the code unit wise. A particular unit of code will be tested, and functional, uh, whatever the functional is constituting the program, each and every function should be tested against this functional testing, as well as integration. If you are integrating all the functions, that integration testing should be performed, performance testing. So many number of testing should be done automatically, right? So there are so many number of tests which are available. It has to be done automatically, so only it is represented as rarely implemented. Most probably it will be manually validated, and it will be sent to the production stage. That is what continuous delivery. And then the second point, it also allows you to automatically deploy to a production environment without any approval action required. So that is what I have specified earlier. So after staging, it will go to automatically to acceptance test, and to the production also it will go automatically, right? So that is how it provides the entire diagram similar to continuous delivery. The only difference here is, in continuous delivery it will be manual, but here it is auto. That is the only difference, right? So here we are having two techniques to implement this. So first technique is, it is implemented by using implementing future toggle technique, right? So which is also represented as future flags, which involves encapsulating the application functionality in features and activating its features on demand, and directly in production without having to redeploy the code of the application. Directly it will be automatically fed to production environment. So the first technique is by using feature flags, which will encapsulate the application functionality and activating its features on demand. So second technique is to use this blue green production infrastructure. So what is this blue green production infrastructure? So here we will represent two production environment. One environment is represented as blue, and another environment is represented as green, right? So one blue and one green. First we deploy to the blue environment, and if all the test cases are validated, automatically it will be sent to the green one. This will ensure the this should be ensured such that there is no downtime for the application, right? So this is the second technique. First technique using feature flags, and second techniques using blue green production. So it requires strong testing and rollback strategies. Since it is implemented as auto, it requires strong testing, which consists of all test cases and rollback strategies. If something happens if for example, if there is a downtime because of the code which we have pushed to the production environment, or if there is some errors due to that pushing of code to the production environment, then there should be a rollback strategy where it works fine, right? So rollback strategy is very much important. So next we will move on to the next. So this is a diagram for a continuous deployment pipeline. It consists of continuous integration part, as we have said earlier, and also continuous delivery part, where in delivery part we will have represented here as manual, that is changed to auto here, right? So that is the only difference. So next, third topic, understanding infrastructure as a code. So we will see the definition of infrastructure as a code. So IAC is the practice of managing infrastructure using code rather than manual configuration. So everything will be done through code. That is what infrastructure as a code. Configuration will be done through code, and that is what represented as infrastructure as code. It is a process of writing the code of provisioning and configuration steps of infrastructure components, which helps automate its deployment in a repeatable and consistent manner. So, this is what the infrastructure as a code works. It automates its deployment in a repeatable and consistent manner. So, why IAC? Why we are going for IAC? So, to provide automates provisioning, reduce human error, that is the first point. It has to provide automation, and then it has to reduce the human error. Second one, it enables version control and repeatable deployments. So many number of deployments of versions will be available, so it should also handle those repeatable deployments in that. So third one, enhance scalability by quickly spinning up or modifying infrastructure. So that is also possible in this IAC, infrastructure as a code. Scalability. So fourth one, at benefits of IAC. So we will see what are the benefits of IAC. First benefit is consistency, scalability, efficiency, and then security and compliance. First is consistency. Eliminates configuration drift across environment. That is what consistency. It should be consistent throughout the process, from the starting to the end process. Scalability. If there is any rapid infrastructure changes, if the resources should be increased, or if the resources should be decreased based on the need of the resources, it should be done, right? So that is what scalability. And then efficiency. It reduces manual work and speeds up provisioning. That is what efficiency. Security and compliance. It ensures no third party users who are unauthorized to enter should not enter into it. So this is a very main point in this benefit of IAC. Security and compliance should be ensured, right? So it allows the creation of self-service ephemeral environment that will give developers and tester more flexibility to test new feature in isolation and independently of other environment. Next is IAC language and tools. What are the languages and tools are used for IAC? So first we will see the language and tools that are used for writing the configuration of IAC. There are different types. One is scripting, declarative, and then programmatic. These are the three language and tools that are used: scripting, declarative, and then programmatic. First one is scripting type. Bash. So some of the example of scripting type tools that are used are Bash, PowerShell, that is used for different client SDKs, and that is also there is also cloud provider tools. Example, Azure CLI, Azure PowerShell. Example, Azure CLI. This is an example how to create the resource group for Azure CLI. AZ group create, location Western Europe, and resource group my app resource group, right? So these are some of the examples which are available in scripting types. right? So Bash and PowerShell can be accessed locally, but tools like Azure CLI and Azure PowerShell are provided by the Azure cloud provider. So we will see one. There is one of the problem in this scripting, that language tool. It requires lot of lines of code. That is the disadvantage of it. And the advantage here is it is useful for tasks that automate repetitive action to be performed on a list of resources, right? So advantage is repetitive actions to be performed on a list of resources, and the disadvantage is it requires lot of lines of code. Next type, so far what we have discussed is about script type. Next is declarative type. These are language in which it is sufficient to write the state of desired system or infrastructure in in the form of configuration and properties. So example for declarative types is Terraform, Vagrant from HashiCorp, and Ansible. Ansible is nothing but we will use to see ANSI, right? So Ansible, Azure ARM template. So this Azure ARM template, once again, it is provided by the cloud provider Azure Bicep, right? So these are some of the examples that provide declarative types. For example, the following Terraform code allows you to define the desired configuration of an Azure resource group. So this is an example of Terraform code which defines the desired configuration of Azure resource group. So if you see here, it represents the resource name and the name of the resource and where it is available, the location of it, as well as the tags. Which object you are going to represent as an environment will be provided in the tags. This is an example of this Azure resource group. So the third type is programmatic type. So this is done to create more union between developers and operations, so that we see the emergence of IAC tools that are based on knowledge known by the developers, right? So far whatever we have studied is script type, declarative types. We have to follow the type which is provided by the tools which what we have seen as example, right? For example, in a script type we have seen Bash, PowerShell, as well as Azure CLI, etc. And then declarative types we have seen Terraform, background. So you have to stick on to the syntax which is provided by the script type or declarative. But in programming types, the developers can stick on to the programming knowledge, whatever they have learned. From there itself, they can implement this type of IAC, infrastructure as a code. So, such as we will use this TypeScript, Java, Python, and C hash. These are some of the examples. And the tools which are available are Pulumi and then Terraform CDK. So here we will see an example for Terraform CDK, which is similar to how to write a program in a Java, right? So we are importing the construct, as well as we are importing app, Terraform stack, Terraform output from the uh, CDK TF package. As well as next we are going to import the resource group from this corresponding link, and then we are creating a class with the name of Azure RGCDK, and that is also extending the already existing class, that is we are inheriting from this Terraform stack. And then we are using constructor, and it is representing the parent using super keyword, super function. And then these are some of the attributes which are available, and these are the features. So here we are representing the name of the resource, my app resource group, and the location is West Europe. And here we are creating a new resource group which is given as the syntax similar to Java. And now what we are doing, we are creating an object for this app, as well as we are we are calling this Azure new group, resource group, by passing this arguments. And this is one of the method that is used along with this app, app.synth, right? So that's all about programmatic type. So far we have seen script type, and then a programmatic type, and one more is represented as declarative type. Next we will move on to IAC topology. So in a cloud infrastructure, IAC is divided into several topologies. So these are the four topologies which are available under IAC: deploying and provisioning the infrastructure, server configuration and templating, containerization, configuration and deployment in Kubernetes. So first we will start with deploying and provisioning the infrastructure. So provisioning is the act of instantiating the resources that make up that make up platform as a service and serverless resource types such as web app, Azure function, or event hub. Like that, we can represent any type of web app. So the entire network part that is managed, such as VNet, subnets, routing tables, or Azure firewall. The network part is also managed, as well as the virtual machine resources is also updated. Only the resources are updated, not the content of virtual machine. So provisioning tools we can use this, such as Terraform, ARM template, AWS Cloud Training, Azure CLI, PowerShell, and also Google Cloud Deployment Manager. So these are the tools that can be used for this. Next is server configuration. This step concerns configuring virtual machines such as hardening, directories, disk mounting, network configuration, and middleware installation. There are different configuration tools such as Ansible, PowerShell, DSC, Chef, Puppet, and StarStack. Right. So these are the configuration tools which are available. An immutable infrastructure with containers. Containerization consists of deploying application in containers instead of deploying them in VMs. Right. So we know a best example for containerization is Docker. Right. So immutable infrastructure which containers this which is represented as containerization. We have seen four types, right? So one is represented as deploying, and server configuration and templating also we have completed, and then containerization. Deploying and provisioning infrastructure, that is what we have seen as platform as a service, and some example based on resource types. And then for server configuration, we have seen some of the tools that are used is Puppet, StarStack, PowerShell, Ansible, etc. Now what we are going to see, it is based on containerization. So here the container technology that is used is Docker. Docker image is configured with the code of Docker file. So Docker file is mandatory to implement the Docker file configuration, right? So without that you cannot execute that Docker file. So this file contains the declaration of the base image which represents the operating system to be used, additional middleware to be installed on the image, only the files and binary necessary for the application, and the network configuration of the ports. So here is an example of Docker file which is given as an configuration file. Docker file is nothing but a configuration file for the container Docker. So unlike this virtual machine, containers are said to be immutable. So that you can, from this line you can infer that virtual machines are mutable and containers are immutable. The configuration of container cannot be modified during its execution. So this is an example of Docker file. So here we are using an Ubuntu image from Ubuntu, and we are running this update apt get update. So in that Ubuntu image, then we are running the ngx. This is the ngx engine. So that what we are going to install in that Ubuntu image, and the entry point for this ngx engine is represented using this user has been ngx, and hyphen g is another parameter, and daemon off, and the port which is used here is 80, right? So here the image what we are using is ngx in the image of Ubuntu, as well as the port what we are using here is 80. So the last type is configuration and deployment in Kubernetes. Kubernetes is a container orchestration. It is a technology that most embodies IAC because of the way it deploys containers. The network architecture, it consists of load balancer, ports, and so on, and volume management, as well as how it protects sensitive information, all of which are described in YAML specification file. So now we will see an example of Kubernetes implementation using YAML. YAML is nothing but you have learned about HTML as well as XML. HTML is represented as hypertext markup language, XML extended markup language. So YAML is representing yet another markup language. So before that we have seen Docker file configuration. Now we are going to see Kubernetes file configuration using YAML. So here we are representing the API version, and kind is deployment metadata. So here also we are going to use the image ngx, name ngx demo, and then we are going to create two replicas. That means two copy of this will be created. That is what replicas. You can specify any number of replicas so the loads can be balanced. And then selector, and here we are representing the image ngx template. Metadata is also representing this ngx, and then the containers contents of image ngx, and the port what it is using is 80, right? So last what we are going to see is DevOps evaluation, so which is GitOps. GitOps is a new DevOps approach where Git is a single source of truth for infrastructure and application. So GitOps workflow, which is commonly applied to Kubernetes, consists of using Git as a only source of truth. Git repository consists of code of infrastructure state as well as code of application to be deployed. A controller will oversee retrieval of Git source during a code commit, executing the test and redeploying the application. So committing, executing of code as well as redeploying will be done by this Git. And the benefits of using GitOps is faster rollback, better collaboration, and improved security. So now we will just summarize what are the contents we have gone through this chapter 1 of unit 1 introduction to DevOps. DevOps promote a faster, automated and reliable software development. IAC infrastructure as a code ensures consistency, efficiency and scalability in infrastructure management. Adapting CI/CD and IAC practices lead to smoother and more automated deployments. Thank you.